Hello everyone, welcome to this channel. My name is Arnab. I have started this channel to practice DSA. I am doing it like this because it really helps me to face something similar to how we do in interviews. So therefore it will help me in thinking as well as how to approach questions. If you are looking to videos uh, where you can get the explanation of this problem, then this is not a video like that because I am very bad in explaining. There are many great YouTubers out there who can explain really well, so I'm just here to practice and nothing else. If you want to just see how I code, or if you want to do something similar to this, then please stay around. So I'm starting with Leetcode top interview 150. This is the study plan, top interview 150, and today I will start with Leetcode 207 course schedule. This is a graph problem. uh, I have solved few of the problems before, but I will be recapping those because I want to uh, because I want to go sorry because I want to practice them again. Okay, let's start with course schedule. Okay, so here is the problem statement. There are a total of num courses you have to take level from 0 to num courses minus 1. You are given an array prerequisite where prerequisite I equals to aib indicates that you must take course b1 first if you want to take course a1. Alright, for example, the pair 01 indicates that to take course 0 you have to first take course 1, return true if you can finish all courses, otherwise return false. Okay, let's see by doing some drawings. So what they have told is that let's create a graph first. Let's say a b c f. Okay, let's join them. We are just creating a graph, nothing else, to understand how to approach this problem. Okay, and also let's see, let's take one more direction here. Okay, cool. So this is a graph. So it starts from A and it goes to B, C, D. Now what we have to think here is that where it goes. Okay, it says that we have an array prerequisite where if if the array says 0 and 1, that means we have to take first course 1 to do course 0. So let's say this is the course 1, this is 1, and this is 0. Okay, so that means you have to first do course f, then you can do course 0. All right. So to approach this problem, we have something called in degree array. In degree array means, let's say we have this array. How many nodes? 1 2 3 4 5 6. So 1 2 3 4 5 6, and each will denote a, b, c, d, e, f. Okay, so in degree array means you have to first you have to calculate how many in arrays are coming to each node. All right, so if we see, then a starting node will be a, so no arrows are coming, so therefore it will be 0. In b it is 1, in c it is 1, d you can see that 2 arrows are coming to d, so therefore it will be 2, e 1, f 2. All right, so this is called the in degree array. In degree array, cool. Now what we have to do is we have to take a queue. Okay, let's take a queue where we have to see which we have to take the 0 in degree element. So as you can see, a have the 0, so we pick a and put it in the queue. Okay, this is queue. Now we will run a loop until this queue is empty. So we pick up queue, print a, and if we pick a, then we have to see which element will get, if we remove a, we have to see which element gets affected. As you can see, if a is removed, then this arrow and this arrow will remove, so therefore the in degree of b will become 0 and in degree of c will become 0. Now we again scan this, and as these are 0, so we put it in the queue again, b and c. Okay, now we pick the first element from queue, b, we printed b, then we see which element get affected. If we remove b, then this arrow will remove, then d will have only one in degree array, so d's in degree will become 1. Anything else? No. So now we pick the third element from queue. We remove c, we print c and see which gets affected. If we remove c, this arrow and this arrow will be removed, so therefore this in degree will become 0. As soon as it becomes 0, we add it to the queue, and e becomes 0. Since it becomes 0, so we add it in the queue. Now we again pick the top element, print it. If we remove d, then this will get affected, f will become 1. Then we remove e, print e. If e is removed, this will become 0, this will remove, and this will become 0. We add it to the queue, remove f, print f. As you can see, we get this list, and this list represents if like how many courses we have taken, and it's in a topological order. So this list is called topological order. This list represent in which order we have to take the nodes. All right, in here case it represents in which order we have to take the num courses, but the courses doesn't require the order in which you have to take the course. It's only asking you whether you can finish all courses. Now how we can say that we can finish all courses? Let's say we are given 6 nodes and we also get 6 nodes in the topological order. All right, so that means we can take all courses and therefore it will be true if any one node is missing. So let's say E is missing from here, so that means the topological order length will be 5, whereas the given nodes is 6. So that means we can't do all the courses and therefore it will be returned false. There is another question in Leetcode where you have to return the number of, in which you have to return the order of courses in which you have to take the courses. That will be coming up next, but yeah, in this question you only have to say if you can finish all courses. Now let's implement this. Okay, first we have to create the graph. So for creating the graph, let's take a list of integer. New linked list. Okay, or you can take arrays, it's fine. We have created the graph list. Now we have to also take a in degree array. It will be same as the num courses. Okay, we also have to create a queue. Okay, is there anything else? Graph, queue, topological order. Yeah, we also create a list of topological order. Integer order, the new linked list. Okay, first we will create the graph. For creating the graph, let's visit the prerequisite array. P of 0. Note that this will be a directed graph, so therefore we have to see, we have to take course B before A. So therefore okay, first we have to initialize the graph list for int I equals to 0, I less than num courses I plus plus, graph dot I forgot the method, it should be graph. Is it like this? I actually forgot. Equals to new array list. I think think this will do. Let's see if some error will come. We will fix that later on. So we have to do graph dot get. I think it will be this. Put leave it b dot add a. So what it will do is it will put the a node. Sorry, if we it will, okay. That means you have to put a b. Okay, cool. Okay, so I think I have done some. I can feel that I am doing something wrong. I guess since it's error list, it will be up. It will not be I. It will be just add new error list. Good. So then we have for the graph we have to add b to a. Alright, then let's just then also we have to increase the in degree of b plus plus, because let's say we are building this graph, so a will have b and c, so therefore in degree of b and c have to be increased. Plus plus. Cool. Now we will run a loop to in this in degree array. The I equals to 0, I less than num courses I plus plus, and if in degree of I is 0, then we will put q dot offer will be I. Then we will edit if it is 0, then we will put it in the queue. Okay, then we will run a loop while q dot size is greater than 0, or if till q is not empty. Let's pick up the top element. Top element will be q dot, what was the method, q dot poll. Yep. So we pick up that and we will run it to, and we will run to the graph to reduce the in degree. Okay, for it's an array list, so for int neighbor equals to graph dot get top. Okay, so in degree of neighbor will be minus minus, and if in degree of neighbor becomes 0, then add it to the graph again. Cool. I guess that's it. Let me just dry run it. Okay, we created the graph, we initialized the graph, we created the graph, then we add the 0 node to the queue, remove the, oh yeah, we haven't added to the topological list, so topological dot add will be top. Yeah, now we ran to the neighbors basically means the nodes that are connected to the given node. Then we decrease the integrity of that node, and if integrity becomes 0 we add it to the queue again. Now we just have to return topological order dot size equals to num courses. If it is same, then it means that we can finish all courses. If it is not, then we cannot finish. Let's just run it. Okay, it's, yep, it's accepted. So I guess that's it for this. There is one more questions, course schedule 2, where the problem statement is same. For example, the pair indicates that it course 0, you have the first take course 1. We just have to return the ordering of courses. You should have to take to finish all courses. If there are many failure, return any of them. It is impossible to finish all courses, return an empty array. That means the same thing, you have to just check if you can finish all courses. If you can, which in case we just have to return true, but in this case we have to return the order of the courses. So till here it will be same. We created a topological order, we did integrity and added to the queue, everything is same. It says that if you can't finish all courses, you have to return an empty array. So therefore you have to return an empty array. If you can, then you just have to create a array of with the same size, and you just have to return a topological order. Since it is an array list, but it expect to return int, so therefore you just have to convert this array list to an array, and you just have to return this answer. Cool. So that's how you can do the course schedule and course schedule 2. These two are already done by me. This was the third and the fourth one. Tomorrow we will do clone graph, and if time permits we can also do the if division. So that will complete the graph general one. So yeah, see you in the next video. Thanks. If you are till here, then I really appreciate it. This is the very first video of mine, and yeah, thank you so much.